Draw a circuit diagram of an NPN transistor with its emitter base junction forward biased and base collector junction reverse biased. Briefly describe its working. Okay, we'll see the diagram here, circuit diagram. This is the NPN transistor with its base junction pointing the forward bias, that is emitter, and base collector junction the reverse biased. This connector it is in the reverse biased. Okay, how it working we'll see now. When the emitter base junction is forward biased, when the emitter, if this is the emitter, it is in the forward bias junction. The negative pole of the battery. The negative pole of the battery is connected with N diode and the positive pole is connected to the P diode. Okay. Electrons or majority carriers repel towards base due to the negative potential on VEB, which combines with the holes present in the base. As here the base is thin, most of the electron will go to the collector. Okay. In the active mode of the transistor, emitter base junction is forward biased and collector base junction is reverse biased. When the transistor operator in this mode, collector current increases linearly with the base current. So in the active state, it exhibits a low resistance at emitter base and a high resistance at its base collector. Okay. Now, this is the second part. Derive the expression for the voltage gain of a transistor amplifier in CE configuration in terms of the load resistance RL, current again beta A and input resistance. Explain why input and output voltages are in opposite phase. Okay, we'll see by applying the Kirchhoff's loop rule to input loop. Okay, we have this circuit with the capacitor and the resistance. Okay, and it is connected to the RL and the capacitor 2 is also there in this circuit diagram. Now, we know here that delta VBE is equal to delta IB multiplied by RB plus RI, where IB is equal to the base current, IB is the base current, RI is the internal resistance, RB is the base resistance. Then output loop, that is a delta VCE, output loop delta VCE is equal to minus RL delta IC. Okay, then voltage gain here, it is AV is equal to V0 by Vi is equal to delta VCE divided by delta VBE. Then AV is equal to minus RL delta LC divided by delta IB terms RB plus RI. Then delta the AB is equal to minus beta AC into RL divided by R, where beta AC is equal to the current gain in CE, which is equal to delta IC divided by delta IB. Well, right, the important consideration which are to be taken into account while fabricating a PN junction diode to be used as a light emitting diode LED. What should be the order of band gap of an LED if it is required to emit light in the visible range? Draw a circuit diagram and explain its action. Okay, we'll see that first. While fabricating a PN junction, the important consideration are the following. Like this is the junction circuit. Okay, it is connected to the battery, that is positive and negative terminal. Okay, we need to consider the points like they should be heavily doped. The first point is they should be heavily doped. Second point, encapsulated with a transparent cover for visible light. Okay, and the order of a band gap of an LED if it is required to emit a light in the visible range is 1.8 eV to 3 eV. Okay, the bandwidth is 1.8 eV to 3 eV. When the diode is forward biased, electrons are sent from N to P side and holes are sent from P to N side. At junction boundary, the excess minority carriers recombine here with majority carriers, releasing energy in the form of photons. Okay, next B. Draw the VI characteristics of an LED. State two advantages of LED lamps over conventional incandescent lamps. The two advantages of LED over the ordinary lamps are low operation voltage, that means the LED having low operation voltage is required very less, and fast switching capacity. Okay, and the VI characteristics of an LED will be looks like this. Okay, here the I and here the volts is there. As the current, that means if it is increases, the old is in volt or increases, the I, it is also increases gradually. This is the VI characteristic of an LED diagram.